Properties of asymptotic notation. First is reflexive property, that is called reflection or mirror image. So what we have in this, if a comma a are such that for all a belongs to that set, then this is called reflexive properties. So what we have in asymptotic notation, first we have fn is equals to big O fn, fn is equals to omega fn, fn is equals to theta fn, and fn is equals to small o fn. So here, as we know, in big O, fn is less than or equals to gn. So big O will go to equals to condition and small o will go to fn less than. So because this is reflexive property, so both should be equal. That's why this will not be equal, because this identify the less than condition. In the similar way, fn for omega condition, fn is greater than or equals to gn omega gn. So here equals to condition apply for omega, but for small o, but for small omega it is for greater than condition. That's why this doesn't satisfy small omega. This doesn't satisfy the condition because it always follow fn greater than omega gn. And theta we always know it is for equals to condition, so this satisfies this condition. So these are the properties which belongs to the asymptotic notation in respect of reflexive property. So fn is equals to omega gn, fn is equals to big O fn, fn is equals to omega fn, fn is equals to theta fn, but fn does not equals to small o fn, and fn does not equals to small omega fn. Now move to the next, that is symmetric property. So over the set A, suppose we have r is equals to x comma y, if y comma x belongs to R, x and y and x both should belongs to R, then this is called symmetric property. Or by example we understand, if we have a set in which we have 1 2 3, so what can be in the set can be 1 2 2 1, 1 2 2 1, or 1 3 3 1, 1 2 2 1 and 1 3 3 1, or r is equals to empty string also. This is also symmetric. This is also symmetric. So according to the asymptotic notation, what we will have, if fn is equals to big O gn, then gn is equals to big O fn. Sometimes it fails, sometimes fail, because both should present. If a set is in which we have 1 2 3, then 1 2 and 2 1 both should present. So sometimes it fails. If fn is equals to omega gn, big O gn, then gn cannot be equals to big O fn. Sometimes it fails. And in the similar way, if we have fn is equals to omega gn, then gn is equals to omega fn. Sometimes it fails, sometimes fails. And if fn is equals to theta gn, then gn is equals to theta fn. That works always, that doesn't fail. That works always, that doesn't fail, because it satisfies always equals to condition. And D, Fn is equals to small o Gn, then Gn is equals to small o Fn also fails. It doesn't work because both cannot be equal, as we know that they satisfy the less than condition, the case of small o. And E, in the similar way, Fn is equals to small omega Gn, then Gn is equals to small omega Fn, doesn't satisfy the condition. So these are the symmetric property based on asymptotic notation. Now move to the next, that is transitive property. That means if A goes to B and B goes to C, then A goes to C. That means A is less than equals to B, B is less than equals to C, so A is less than equals to C, so A is less than equals to C. So big O will be true. Or we can understand with example. Suppose 10 is less than 20 and 20 is less than 30. So big O notation will satisfy here. In the similar way, 30 is greater than equals to 20, 20 is greater than equals to 10. So in that way we can say omega will be true, and 10 is less than equals to 10 is less than equals to 10, then if like that, then theta will be true. In that way we can satisfy the asymptotic notation. So we can say if Fn is equals to big O Gn, and if Fn is equals to big O Gn and Gn is equals to big O Hn, then Fn will be equals to big O Hn. So in that way this will satisfy the condition. And if Fn is equals to big O Gn, then Hn Fn will be equals to big O Hn Gn. Then Hn dot Fn is equals to big O Hn dot Gn, where Hn should be positive function. If it is positive function, then if we have condition Fn is equals to big O Gn, then if we multiply it with Fn and Gn, Hn function which is positive function, then this condition will satisfy, then this will be true. So these are the some reflexive properties which belongs to the asymptotic notation.